Executive Director of ACA Automation Private Limited. He is a diploma holder in Electronics and Communication Engineering and has done an MBA in Marketing and Sales. He has close to 30 years of experience in weighing and process automation solutions. Ahead of his time in ACI, he has served as the regional manager, South India, in Sartorius Mechatronics India Private Limited, subsidiary of Sartorius AG Germany, a leading multinational weighing and automation company. He has visited more than 300 foundries across India. And talking about ACA Automation, it has close to 30 years of experience in weighing and automation solutions, headquartered in Chennai. It is closely working with foundries across India for the past 12 years for weighing and process improvements, and associated with companies like Brakes India, Bhagwati Sperocast, Mahindra CIE, Nelcast, Mando Automotive, having their regional representatives in Delhi, Kolkata, Ahmedabad, Kolhapur, Hyderabad, and Coimbatore. ACI has been having stalls and participating in IFEX since 2014 onwards, close to 10 years or 11 years now. And in the past 3 GIFAs, they have been participating, 2015, 19, and 2023. And their key products and solutions include integral type crane weighing systems for molten metal and raw material weighment, having close to 400 plus installations across the country. Auto alloy feeder for SGIN process and furnace alloys. Poka-yoke control systems for alloy addition for SGIN process. Furnace platform raw metal addition, digitalization with Poka-yoke control systems. Furnace metallics and alloy auto weighment and charging. He has been associated with IAF and a member of IAF for more than 10 years and attended all major functions of IAF. Served as IT and Web and Committee Chairman in the last 68th Indian Foundry Congress and 72nd Indian Foundry Congress, which was held in Bangalore. Currently, he is serving as the Vice Chairman of IAF Chennai Chapter, and he is also currently the Chairman of the Long-Term IT Committee for 2024-25. He has written a lot of papers. Actually, he's presented a lot of papers during various National Foundry Congresses and technical seminar organized by Dynamic Foundry Group and many more in ISCON and National Foundry Conclave. And that's a small introduction about Mr. Sendil Kumar. He's a well-known figure, and we are truly happy to have him with us here today. Mr. Sendil, the floor is yours. Sir, mute sir.
Oh, thank you, Mr. Vignesh, Chapter Chairman.
Yeah. Yes.
Yeah, let me get my screen first. Is this visible, Shivashankar?
Yeah.
Yes, sir.
Yeah.
Good afternoon, fellow Foundrymen. It gives me immense pleasure and honor to share the session with you, all of you, on this great afternoon session. And first of all, I would like to thank IIF NCSD team and IIF Chennai chapter for giving this great opportunity. My special thanks to NCSD Chairman Dayalan sir and Chapter Chairman Mr. Vignesh. And I would like to express my gratitude to all the members who have been participating this particular seminar. I'm sure that everyone is very busy. I think we have sent out this circulation for all our members. I could see only the few members could join, but the time is more valuable. Thank you for sparing your time for this particular session. And before stepping into today's topic is automation of economics and operation in melting. I just give a big few background. In fact, we have presented this paper in IIT Tirupati for the course of digital manufacturing and the introduction of AI and ML learning. That's a one-day session. Almost about 6 hours session it was. And I am asked to present the same paper through this webinar, maybe 1 hour, 15 minutes time. I try to cut short and give a crisp data through this webinar. Hopefully, it will be more interesting to you. Okay. Before starting, I think the introduction has been given. The short from my side, I think ACI is, we have been working in this industry for the last 30 years, and we more focus on the melting platform automation. I think that's why we have been asked to present this particular paper. And we have been serving close to about 200 foundries across the nation. Okay. Before going this, I think we are all know anything. Earlier days, we used to, any subject, any doubts, we used to talk with our seniors or maybe the veterans in the industries. Later, we moved to Google God. Google God is the place where we ask all questions. In fact, still people are using it. Maybe if you go and meet doctors, if the doctor subscribes any medicines, now we have a habit of checking with the Google that whether it is right, what is the complications, all those stuff. Now later Gen Z generation has moved to ChatGPT. I'm sure that everyone is well aware of ChatGPT. I think that is AI tool become one of our day-to-day indispensable tool. Even I understand that even college students, school students started using this for day-to-day usages. Yeah. Uh, Other topic subsides, I thought, okay, let me ask a question of ChatGPT. What is automation? This is what automation is defined. Typically, it involves machines and robots and computers program to perform specific tasks without my human intervention or little less of human interventions to achieve the repeatability, accuracy, more productivity, so on. Okay, what is that? Talk about automation and economies of operation in melting. It's a new acronym, and when I put that question, these are the answers are coming in. It is automated control system, energy efficiency, labor saving, improved safety, and then in data monitoring, integration with IoT, scalability, flexibility, quality control. I think we are all aware that okay, these are all very important factors. And why this automation comes in a picture now? What is that? Because foundries is the mother of all manufacturing industries. It is there for so many years. And what is the need of automation? And we have been talking about more than a decade: automation, digitalization, IoT, all those things. See, now it's become mandatory for almost all the places. Like people know the business process, any stage of business, like business spaces, people talk about your struggle phase, survival phase, stability phases, success, and scale up phases. Earlier days, we need to, for the scale up, we need to all improvement for automation, all those stuff. But now even at the survival phase, it's become very important to meet I think new norms like ESG, carbon credit tax, digital reporting, okay, all those coming in pictures. Now even a startup company in the foundry needs to spend good amount of time and money in these aspects. That's why it's become more important and evident factors. With that consent, let's go for it. Basically, before going, I would like to have a declaration, and we'll be discussing about mainly on the ferrous foundry process, not on much on the non-ferrous. And as in the foundry ferrous process, there are various manufacturing processes are available, but we will be able to discuss due to time constraint only few process. And the more important factor is I am not a practical foundryman. Basically, I am from the weighing and automation background, and all my knowledge is gathered from the big foundry fraternity. And more of my talk would be instead of process, more of equipment and the automation side. That's what I'm trying to emphasize it here. And I'm also trying to use past, present, future timeline. This is only for indicative. It will have overlap. Maybe when I talk about past, we'll be using that is also in the present. When I'm talking about future, that some people might be using in present conditions also. Yeah. When we talk about the foundry, this is the main process. Like when you look at it, two major categories. One is the sand plant and mold making. That is the other side of it, where the typical layout would like this, where pattern making, core making, sand plant, and mold making comes in the picture. And then other part of it for the molten metal preparation and pouring. This is a typical layout of the foundry, where molten metal making, edge treatment, pouring, peddling, all these places comes in cases. We would be restricting our today discussion mainly on this area like molten metal making, edge treatment and pouring, where we would like to spend our time. See, as I told you, this is a topic which I took it in IIT Tirupati in the month of July 2024, and since we had a time, we had opted for the poll to the participants. Know what are the factors affecting the melting operations? This is a day-to-day problem every foundryman faces, and I also would like to have a poll, but due to the time constraint, I'm not doing it here. The result I got from people, this is what the various points have come out from the people. Like people talk about less automation and then temperature issues and the charge mix. These are the factors have come in. Maybe you also must be having the similar line inputs, I presume. If you have anything more, you can put it on the chat box, which can give me an idea, and which can be used for further seminars, whatever the improvement of my presentation at a later stage. So the phase at which I'm going is okay?
Sir, okay, sir.
Yes, sir.
Okay, fine. Thank you.
Hello, Tim. This is from Vijay Technocrats. Can you hear us?
Yes, sir. Yes, sir.
Okay, thank you.
Thank you. Yeah, as every foundryman knows, we'll start with the any melting process. We charge with a molten metal charge mix. That is the one of the prime most activity. And as I mentioned, that earlier days we used to use of manual calculations, and where we depend more on the experts, veterans who have been working in the foundry industries. All their knowledge or expertise are there in their mind and heart. We used to depend on them, and then there's a lot of manual calculation happens. I was told there are some stages where if the experts are not done for the particular day, the productions also got halt. That is the stage. I think it are all olden days. Now almost now people started using kind of Excel sheet where the people can punch in the data with their what is the charge mix and then the content of carbon, silicon, all those stuff. I'm sure everyone must be having some kind of the sheet. I can show that few sheet which I have gathered from the industries. Okay, this is the cost and with the typical charge calculation sheets. And for the particular gate, what are the pig and how much weight has to be used, what is the carbon content. And this is the typical sheet people use. And for the cost optimization, whether I have to use more borings, less borings, all those things comes in a picture. People use more borings to reduce the cost and those kind of stuff. I'm sure that most of the foundry must be having this data Excel sheet, which is tailor-made for their own expertise. And then the tool, like there are in Indian companies like people like Now Purchase, Optimics are having the charge mix software as such, which can take the input of your raw material chemistry, and then even considering the cost of raw material, they can arrive the optimum level of the charge mix. I'm sure that, but charge mix like this is what charge mix of metal clouds is from the Now Purchase. They offer in terms of SaaS model, and they are well penetrated in the market, and I am sure many of the people are started using it. And Optimics also from other vendor from Ahmedabad is also doing a good job in this industries. I think if the people are not using it, I would strongly recommend to go for this tool, which will minimize the risk of depending on an individual. It can optimize the data. See, more than this, like this is all arithmetic or a linear programming based tool, and the later what we can think of it is data analytics. But when I'm talking about all these tools, the main tool Excel sheet or the charge mix, but I understand apart from the pure calculation, that are your as a veteran foundryman, you have a lot of other inputs, like you have to add certain amount of pig iron for 10 to 20% to nucleation, better nucleation, and then sufficient mild steel to get the toughness. I'm just giving a 2-3 points which I got it from the foundry veteran. And for the ductile iron, there are you have to reduce the sulfur. All these things are based on, but this is the knowledge. This knowledge is not captured in the Excel sheet or in the tool. This is not at all available. That is why we need to get into the where the human touch is also required, and then maybe the later stage AI or data analytics can help us. Maybe based on your past data, data analytics or AI can help you to arrive the proper charge mix for your particular industries, for your particular grade, based on your past data, which covers all your expertise. There are people who are working on it. Maybe future it will come out in the market. I think I understand that Metal Cloud started giving even WhatsApp. People that the military will get their WhatsApp message that what is the chemistry, what needs to be added. Those data comes to their Android mobile. And of course, everyone started using the spectro display to have the visibility. The second part is, we have to, whatever we talk about the chemistry, then it has to be charged. It has to be put into the furnace. And the selection of the equipment plays a major role in the foundry industries, because once this is done, once it is installed, it is very difficult to replace it, because it's not so easy. Like Indian context, we don't change it overnight. No, we will use it, we will live with that machine, and then if at all we have the unlimited issues and we are not able to cope up, then only we'll think of the replacement. Of course, this involves a lot of the cost, other factors, which is very difficult for many of the founders. Hence, choosing the right equipment, machinery at the project stage, initial stage, plays a very important role. Whenever you're going for any new additional equipment, and good amount of time need to be invested, and then comparative study need to be done, then it has to be achieved. This is one of the main factor which you need to consider. And the second factor, I would say that validation of the equipments, because this is one of the most neglected part. I would say that validation. People have a confusion about the calibration and validation. And calibration is you are correcting the machine for the specific values. For example, since I am from the weighing equipment, weighing side, I would give an example from the weighing equipments. Suppose your balance says about 100 kg scale, and when you put a 100 kg stone, if it has to show the 100 kg, that validation has to be done. That is a validation. If the scale is not showing 100 kg, and you have to correct it by putting 100 kg and make sure that the scale is showing 100 kg. The correction factor is done in the calibration. The validation for that matter is very important. You can have your standard SOP, whether you have to validate for a daily basis or on a weekly basis or monthly basis for any equipments. It can be a weighing equipment, it can be a temperature measurement, it can be a pressure, even for your spectrometers, for the results. All these equipments has to be validated with a proper time interval. And see, people like pharma industries, where people use ultra micro balances and all, where they use the balances validation for everyday morning. They have to ensure that the everyday morning that the balances or any equipment are performing to its fullest assured accuracy. Then only they will start using for the regular operation. But I'm not. I don't think that much stringent SOP is required for foundry industries. At least we need to think of a weekly basis or a monthly basis at least to validate the equipments. Yeah. See, when it comes to melting platform, mainly our first main product would be equipment would be furnaces. And all the veteran Foundrymen are here, and you all know that people have started with cupola. I think now we almost we could rarely see the cupola furnaces in the Indian market, or I'm not sure about the abroad. At least in Indian market, these populations are drastically coming down, and almost people have gone to the induction furnace. That's what it is now prevailing in the market, various capacities. the major factor which is expected from the induction furnace is energy reduction. Now everybody talks about per ton, what is the energy consumption. That is what the improvement factors. Many of the manufacturer of the induction furnaces working on this technology. What best they can offer. People talk about 520 units per ton, the benchmark, and find people want to reduce to 480 units. There are a lot of research, and some people are committing still in the market, and people are in the they're validating that whether it is providing that much. And one more area where we have talked about the slag removal, which still people are doing it in the manual process. That is also automation is looking for it, and some people have started using this one. This is what induction furnace. As I mentioned, that energy optimization is one of the major area people are working on it, and it is not only for it only the energy optimization. It's not only on the equipment, also on your charge preparations and the sequence of loading. And this is what I was told by veteran Foundrymen. What are the sequence of charge mix and what are the charge material you're using. The quality of the charge material, that also makes a lot of difference in your quality of molten metal output and energy consumptions. And I'm sure that I am not the equipped person to talk about this subject, but it is also one more factor which you need to put on your thoughts, and I'm sure everyone must be having a clear idea about it. Yeah, when second we would talk about as I mentioned that we did the crane weighing system where the molten metals are get weighed, and this is also one of our being our own product. And molten metal, earlier days people used to use a hanging crane to measure the molten metal. Shiv Shankar?
Sir, yes, sir. Muted, sir. Muted, sir.
Yeah,
You can continue, sir.
Okay, please take care. Okay, thank you. The hanging scale is traditionally used, and then what is the issue? Since it is very close to the molten metal, the failure rates are a little higher, and then the replacement cost has become very higher for the people. Then now technology has come for integral type weighing systems where the load cells are put on the equalizer pulley, and then the displays are working on wireless display, so that it's away from the temperature and you can see the weight from the bottoms, and it works on crane power. You don't need to charge the battery and things like that. And one more point is, for when you do a AG treatment, there is a lot of smokes comes out when your scale is located here. When the scale is located here, you got a lot of fumes. You will not able to see a display. Whereas this integral type crane weighing system, there's a wireless display which is kept a little away from the location. It is mounted on the crane top. You can see it from the bottom level without any disturbance. There's also more advantages of this particular type of weighing systems. And it comes with various displays, remote to make zero tire and even calibration. Only for at the time of installation, you need to go top, and rest of the time, the calibration, everything can be done from the bottom level. And when it's used for raw material, you can get a LCD model where it can also show the material name. You can choose the material name and then register it. It will, along with the material name, it gets stored in your local computer. You'll be able to see what are the consumption of the raw material used for your overall ship. That would be the advantage of systems. And I would, as I mentioned, it's one of our own ACA own product. I am requesting people to connect with me privately where we can talk about this subject alone close more than a year. And we have close about 500 plus installations in the market. All major foundries are using these systems. And then molten metal making, metallics and alloys. This is the process where basically raw materials are weighed through manual weighing scale or electronic weighing scale, and then charged manually into the furnaces. This is a typical, and there will be a manual charge sheet. This is what the past things. But this is where the labor intensity work, and then now people are finding it very difficult to get manual manpower for this particular solution, because it's a lot of really hard work. I think it's really hard work, and most of the foundries are coming out of this, and they are not doing this right now. Close to about 70 to more than 50-60% of the foundries have come out of it. And currently people use, this is a typical layout of the foundries, where people use a charger to charge the materials to the furnaces. See, before think of any automation, I would strongly suggest mechanization is very important factors. When I'm talking about mechanization, introducing a charger, we get a lot of inquiries. People talk about automation from this level to top level, but they first need to go for mechanization, introduce all the required start from the vibrators and things like that, then they can think of the automation kind of it. That would help them to go by stage wise things. This is a typical layout for the furnace platform, furnace melting platform. And here again we have developed a solution for Indian foundries, which can kind of semi-automatic. Like when I talked about the automation, I told you that automation is the process where I introduce robots or computers, where I eliminate 100% of human intervention or part of the human interventions. Okay, then to get the consistency of the work and the repeatability of the result, all those things. But when we study the foundry industries, currently for the foundry industries to make it 100% automation would be little difficult task because of the various constraints, uh, be a space constraint, maybe the existing plant layout, and then thirdly, mainly on the material sizes. See, the automation mainly works where your inputs are consistent. Like we always compare our industry with pharma, food industries, and other industries. But if you really go back and do a research, and there all the process as well as the inputs are consistent. Maybe it is a similar in nature, and then get a repeatabilities. When your inputs and process are similar, then output can be made automatic with the help of machines and automation. Output can, but the challenge in the foundry is that is the biggest challenge. Hence, we try to develop kind of semi-automatic systems, and which is been well appreciated by many of the industries. It is it is something like this. We instead of giving a charge sheet to the person, we will have the centralized software where you can create a charge mix, and then you can also put all your chemistry data. Everything can be captured in a single location. If you have SAP, that can be loaded into the SAP, and this is a local NPC software where all the data are captured, and then there are certain equipments are deployed. I just this is a few screens. Yeah, once that all the your masters have been put for the production day, you have to go to the schedule, and then for the particular day, for the particular furnace, what grade need to be manufactured, you have to give input to the system. Then the input, the system would take over further. How the system works, it's like this. Basically, we will deploy a typical display where something like this. Charge mix scoreboard. This is we introduce for each and every furnace, so that whatever charge mix you put in, it gets displayed here. And then there is a push button to register the raw material, and then we introduce the something called batch supervision system. I will explain you what is the functionality of this instrument, and that gives you an idea. See, once you put a charge mix, and there is a display which will show the raw material, what are the how much of scrap to be weighed, how much of foundry returns to be weighed. All those things will be get displayed for the particular furnace for the which the grade is running on. This is going on, and this will be the guiding display for the operator. And for then 1 second, it's not moving. Yeah, here you can do a registration in two part. One is that the manual registration, there will be a push button station, because when the raw materials are brought onto this crane, The crane will not understand whether you are bringing a pig iron or CRC or a boring. Okay, it can understand only the weighment through weighing system. The data will come to the centralized computer, but it may not know the what is the material you are bringing in. For that, to give a confirmation to the system, you need to select before dropping. You need to select which material type. Suppose you are bringing a pig iron, you need to say that I am bringing a pig iron, so that it get registered as a pig iron in the charge mix display. This is the one method where the manual registration is required. And suppose you feel that, okay, I do not want to do it, it will be a manual dependency. The person, suppose he forgets to press a button, then I may not get the proper data. Then you can think of going for crane positioning system, where no, you can introduce the long wing sensor, where it can understand the crane position, CT position. Based on that, it can identify automatically the material name. But your biggest point to be noted is that you have to ensure that the bay in the sequence of material in which you are storing in the bay has to be ensured. Suppose in the bay one you are storing at the pig iron, you need to ensure that all the time you are storing pig iron alone, not a boring machines. Borings. No, if it is RR in the second, then you should ensure that RR are stored in the second bay. You can change it. Maybe when you are changing the inventory, you can change from 1 to 2, but it has to be updated in the system. And it system will identify based on the location that what is the material it is, and then it can read data from the wave mechanization diminution input, because anyway it is operated by the crane operator. Based on that, it knows that okay, I'm taking a material from this particular location, and then when it comes to the charger, we know that it is putting on this particular charger. Based on the location and the management and demanagement input, it automatically registers the data. Yeah, I'll just run small videos which can give you a clear idea to you. One second. See here, I'm showing the registration through manual push button station, and then the bay is not maintained here. That is why the manual push button station has been provided. The magnet is lifting the material. The weighing system is installed in the crane. Yeah, before putting into the charger, the person is registering the material. It get registered. As you see it here, it get registered here. One second, just for clarity and just running it again. Yeah, it gets stored. Suppose they have a foundry return 2000 kgs and 500 kgs getting registered, and remaining weight will also will show, so that it gives a proper idea to the operator how much more he has to bring it to the vibrator, and which furnace is running. It will also give the indication to them, and this data automatically goes to the your computer. And this is the place where alloys are get weighed, and this is the instrument which will show that material name, what alloys to be weighed. Maybe for the example, this carbon to be weighed. It also show the what is the set point and which is for which furnace it is. Maybe furnace A, B, C, whatever it is, and actual weight will read from the weighing scale. And here we introduce some kind of bokeh, where if the person is not weighing the proper quantity, it will also give alert. There is a tower lamp. If the quantity is less, there's a yellow lamp will glow, and if it is proper weight, green will come. If it is more than the set point, then the red will come. They have to, instead of writing it down, they have to press the register button so that the weight gets registered. If it is out of tolerance, it will not allow them to register the weight. In this case, is showing the green, then he is registering the weight. So the charging of the material to furnaces, all those things are going to be a manual. As I mentioned, it's a semi-automatic system, and it will be useful to you. Why it has to be deployed? If you ask this question, what is the difference between the traditional method and this method? Basically, if you look at the challenges faced by the traditional method, is that okay? It's totally depends on the operator efficiency. We are good operator and may not make a mistakes. But when you're talking about mistakes, there are three layers of mistakes we are expecting. One is that in this place, like when you're doing, for example, for the lawyers, when they do a payment, there could be a mistake in payment mistake, and then the data is recorded in the logbook. While recording the logbook, they can write a wrong data instead of 8 or maybe sometimes 0. And then the logged data is again punched into your Excel sheet or a ERP, any kind of tool which you have. No, again, there could be data entry mistakes. Now, all these three stages of mistakes only you get a data which will you use it for your analyzation purpose. Now, what we are trying to do is that we try to take data directly from the instrument and deploying the OK principle and ensure that the right quantity of right material is deployed here. So when I'm talking about the right quantity, of course, that has been done. You have seen the video where this BST batch supervision terminal will ensure that. What about the right material? How the system will understand the right material? That is why if you look at this green bins, where like it looks like a suitcase, when the system says that ferrosilicon has to be weighed, only that particular bin gets opened so that he takes material from that bin and put it on the weighing scale. When the payment is done and the registration is completed, then this gate get closed automatically, and the next material bin is open. So that unless otherwise you want to do intentionally mistake, you will not able to do any mistake for a material replacements. It is basically de-skill the people, and then whatever system says he has to supposed to do this operation. That is the system, and it is being implemented in a couple of foundries, and people are directly using it. And this data directly has been interfaced with the SAP or the centralized data, where this it is avoid for the again data entry requirements. Typically, your charge mix data basically start from your furnace number, what is the grade in which you are producing, and then how much metallics you have used, how much alloying elements used, and it also can take data from the spectro, and then the spectro result can be given the data. When I'm talking about spectro, when your charge mix are completed, we can read data from the spectro. What is the additions and dilution to be done? That is also being done by the that is also being calculated with the help of our software or third-party software. Like as I told you, like Optimix or Now Purchase, we can read data and then integrate with our machines. Like whatever the display systems are available in the market, it shows that how much needs to be weighed and charged. But whereas this particular solution would help you up to your weighing scale location, and it ensure that the operator does that same quantity of the payment. That is the advantage of these systems. And end of the day, the entire charge sheet would be generated from the system without anybody's writing it down, and only by some interruption of some push buttons and some sensors, it automatically produces the data, so that the data when we talk about the digital data is met, whichever is demanded by a buyer, it's met by the systems. Okay, next we talked about the automatic system, which is we talked about future, but it is also being implemented in a few of the foundries in India right now, where we fully automatic. I told you initially that what are the challenges when we talk about fully automatic, but when the challenges are being taken care, and definitely it is possible to implement it. Now, the typically this is what we have done, and this is the layout. After your storage bay, there is a way of material bins have been constructed with maybe about approximately 5 tons of each for all your borings and no other raw materials, and the more vibrator is deployed, which moves on horizontal direction, and that is mounted on the weighing scale. And once your charge mix information goes to the machine, it goes like a robot. This particular charger moves like a robot to a particular bin, collects the material, and come back and stand here for the particular furnace. Say if it is scheduled for furnace A, it stands here, and when the charger comes into this location, it automatically dispenses from here. Here the advantage is that your manpower reduction is very high, and you can operate with about 2 to 3 people overall melting platform. The challenge would be like layout changes and the raw material sizing. Of course, the that plays very important role, because if you have a scrap which is uneven size, it cannot flow properly. It may get stuck in the bin, in the vibrator. Or if you have the CRC bundle, say, which is talk about 150 kg, 200 kg of each, then it's very difficult to attain the required accuracy of charge mix. Those sizing of the materials plays very important role. That needs to be considered, and the cost of getting those material also needs to be considered before people invest on these kind of equipments, because that is a very important factor, and you need to weigh all the options. What is your ROI kind of thing, and what market price you are getting from your vendor, your buyer. Those factor has to be weighed. Then you need to invest on this particular technology. And this is for the major raw materials. For the alloys, we have the furnace alloy feeders, which has got about depends on the foundry. We have the number of bins with the vibrator, and has got a weigh bin, and you can charge it for 1 day for requirement alloys. When the formula comes in, it automatically dispenses the required the weigh hoppers, and that can be collected and put it onto the furnaces. And this is the system which has been talking about quite long, but recently we could do a one installation at one of the place at eastern side, the new foundry which is coming up, and then that is being installed there, and they are successfully using the systems. The advantage of system would be that all the manual errors can be avoided. You are not depending on the people efficiency. The system would automatically dispense the material, and you can collect it and put it on the furnace. And it can also interface with the spectro, and then correction alloys also can be weighed here and then do it. And it is much easier. Again, the one precaution point would be that raw material sizing. Now, if you are adding sometimes, people ferrosilicon, magnesium, or ferrochrome, which is generally on a bigger size. Each piece comes in the range of say 3.5 kg to 4 kg, whereas your required batching accuracy in the range of 100 grams to 200 grams, which is very difficult to achieve. Typically, your granular size of the weight material says about, if you say 10 gram, then you can expect accuracy in the range of 2 to 4 times of that particular granular size. That is what we are able to precisely control the feeding of those material. That makes a lot of important factor. When you decide to go for the system, then those factors need to be considered. And of course, we are available to provide our input on this subject, whether it would be optimal for you to go for it or go for a semi-automatic system. And depends on your batch sizes and material availability, we can provide our input to you. Okay, I just run a small video which gives you some kind of idea. Very short. This is for the alloy feeder, which is this is a typical drawing which we submitted, which we have supplied to the customers. You have the weigh bin. Start from, say, there are about 6 bins, and there are typically about 3 weigh bins where the materials are weighed. Depends on the charge quantity, and there are the weighing bins have been designed. So this one, I just run this particular video for automatic charging. It's very short video. This is what is the storage bin, and there is a vibrators, and then there is a charger which moves on horizontal direction, and it is mounted on the load cells. See, this you got to consider. See, when I'm talking about load cell, this vibrator comes with a lot of vibration, and there is a very special load cell to be introduced. I would strongly request you to consider go with the experts, because we know the subject. It's not just putting a load cell which gives the performance, because we have learned all these tricks of trade with a very hardened way. Many failures we have seen. Based on that, we suggest a solution which long lasting. And when this go for this kind of automatic system, the reliability plays very important role. Then only your productivity will not have any big impact. The failure of the machine, then again it forces you to go for manual operation, and then manual operation again you will have a very restricted place availability. That is why the selection of the equipment, you need to go and with the vendors, and then have the proper analysis and go for the system. This is communicating through the computer through wireless, because you can have a cable running for this movement. Yeah, this is the controlling this vibrator to material. You can also see the material sizing, how finite it is. Then put it onto other charge. We have supplied the system in Jaipur, and last I would say about 3 to 4 years it is working without any issues, and we are in the discussion with many of the new projects about this particular concept. Yeah. What would be the feature? Like, we have talked about the alloys dispensing and all, because I talked about the collection of alloys manually and putting onto the furnace, but still feel people that again it become manual intervention. And for that, we are in the discussion with a few companies and the conceptualization stage, where even the alloys would be directly dispensed to the furnaces. Like, this is a typical layout where the furnace alloy feeders are put it on the furnace platform or below the furnace platform. The metal is taken to the kind of skip hoist, and there is a charger which moves on top, and that would dispense to the more special pipe vibrator, which is designed to dispense the this small quantity material, small quantity material from the furnace, which travels in between the main charger, and it has got a, it will have a inclination diversion, and it will tilt on one particular furnace and charge the material. It collects material from this particular place, moved straight, and come here, and with the turntable it move on either left or right furnaces and discharge the material. Of course, there will be some interlocks there to ensure that this particular charger is not in near location. The furnace hoods are open. All those interlocks are there. But movement of the chargers are manual, because you need to decide when the alloys need to be fed into the furnace. Charging sequence is not automated, but all this material carrying from the alloy feeder to the furnace, everything have been little automated with the help of various mechanization, chargers, and the vibrators. This vibrators are very specially designed for this particular application. And we are also talking about controlling of automatic magnet pickup and charging to the vibrator. That is also going on. There are few multinational people are offering. Some Chinese people have supplied, but unfortunately we could not see them in the operation. And we are in the R&D stage, where we are trying to, because we have close about 60 to 70% of technologies are available. Only about few fraction of technology we are working on it with our partnering companies, and hopefully we should be able to come out with the solutions shortly. And if anybody would like to interested, we are keen to associate with any of the customer or the vendor on this concept, and then would like to jointly work together and then go for the solutions. Yeah, this is your charger material, and of course your other parameters, your quality parameters, testing parameters also important. One is that temperature is one of the main factor, like how we give a more importance to the movement of raw material, and then the temperature is also important factor. Earlier days people used to use this the contact type, where the dip type, there's the consumables included. Now I think people are moving to the non-contact parameters. I think people like Land Tech has started having this display. We as a OEM supplier, we have tied up with Land Tech to supply our Bluetooth displays, and we supply as OEM to them. They supply in turn to the market. Their percentage of the installations are getting increased. I think there are other manufacturers also available in the market, and it is also ensure the safety of the operators. No, they don't have to go near to the furnace. They can little away distance. They can operate the system, which gives the safety to the operators. And more safety conditions are coming in places. These equipment plays a vital role, and that maybe the future technology would be, this is Whenever you want to check the temperature, you are checking it. But this is a continuous monitoring. See, the disadvantage of the present system would be like, suppose for example, you start a heat and then you want it, you will expect to complete that the heat reach temperature maybe in the 45th minute. If the operator is busy with other activities, it goes to the 50th minute of the heat, then by the time the temperature is achieved and your 5 minutes of the temperature, your energy, all those things are going. There's a productivity loss. All those things are happening. And but this system is a continuous monitoring system with a camera where it can give you the once the temperature reach, it can give you immediate output so that the decision can be taken immediately for taking the sample and then start for your tapping. Other aspects can be continued. And this is technology. I understand that it's getting evolved, and then even though little expensive, maybe you can work on your ROI and then reliability, and then this also can be one of the technology can be implemented in your process. And of course, your carbon silicon analyzers and spectrometers, these are all known equipment where you check your carbon and silicon spectro for the elements, you check that spectral elements. And the thermal analysis is getting popularized now to for your mechanical properties. Now people are talking about thermal analysis. Novasys, Itaka, and even SNAM, and there are other few people are manufacturing these particular solutions. I think it's important to you deploy all this latest analysis tool in your process. Because the spectrometers, what we talked about, you have a various displays are available, and the market nowadays, instead of LED version, now people are converting normal TV as a spectrum, so that customer has got the liberty to choose the size of the TV, and the availability of the TV now become very cheaper, and then the serviceability also become cheaper, and only the some kind of converter box is given, then the data is published there, so that whatever colors you would like to have, whatever the font you would like to have, everything can be customized, depends on the customer requirement. This has become more of available product right now in the market. Many of the manufacturers are providing now. Of course, we also provide as a overall solutions. See, now we have so far we talked about the overall process, like how much material alloys to be weighed, how much raw material to be weighed, what are the checking process, temperature, all those process. But I think when I talk about the SOP, like what sequence material to be charged onto the furnace. I told you when I'm talking about the melting furnace, the quality of the molten metal or the yield or the energy saving. We talked about even charging of the material, charging sequence plays a vital role. That's what every experts talk about it. Now, how do we achieve that with the help of latest technologies? Okay, now camera-based AI tools have come. The company like Surveillance AI is available in Chennai, and there are other players are available where you can define your SOP. What needs to be done first, what needs to be done second, and that process will be captured through camera, and then it also gives required alerts and data to use so that the process can be streamlined. Whether the operator is following the established SOP or not, that can be monitored by these kind of tools. And then, of course, these operations are manual. The only thing is you can monitor it, and then by monitoring it, you can ensure that this is put in place for every process. I think management process, everybody says the rigorous review mechanism that would help for any process to get success. Here, this would help you are in a rigorous review mechanism. This tool would help you to give a data which is not punched in or created by your member, and this is system generated. System camera would automatically generate this data and give it to you so that you get required alerts, and then the process can be improved upon. This is the solution. Of course, it is in the initial stage of evolvement, and there are few vendors are coming up in this. We are not in this line, definitely, and there are few vendors working on this. They definitely would be able to help you, and if you can connect me, and then I will also able to connect with these particular vendors for your process improvement. Yeah. So we discussed so far about the base metal cast iron, which is the process. See, when the cast, once your base metal is ready, then wherever people who are making your AGN, the treatment plays a major role. This is the typical method. I'm again, as I mentioned, that I'm talking about only one particular process, sandwich process. I'm not going to refer about the other process, which is also getting popularized now in the market. But this is a traditional SG treatment sandwich process, which I'm talking about here. Here what happens, like people weigh the required ferroalloy, ferrosilicon, ferrosilicon, magnesium and covering steel, and that is weighed in the manual weighing scale and then put it onto the ladle, and then it is taken to furnace for the tapping. This is total manual operation. The biggest challenge in this that it depends on the operator efficiency, and he has to ensure that he is doing every time this process properly. Since a mundane job, everyday process from the morning to till the night, and there is a possibility of making mistakes in this process. That's a disadvantage of this particular process. What is the challenges? What is that? Suppose if I'm not, what is the challenges in this particular cell? As a foundryman, you are aware of it, because at least for the base metal, you have a time to check the chemistry. If the chemistry is not matching, again you do a addition and dilution. Again, check the sample, and then you go for a tapping, so that your wastage of metal or is not there. But whereas for AG treatment, it's once the treatment is over, because the molten metal is out of the furnace, it goes to your ladle, and out of the furnace, and you need to consume the molten metal within 720 seconds before it loses property. That's one of the important criteria. And this process, what happens once the treatments are over, you are going for a pouring immediately. Then the samples are taken parallelly, and then by the time the result comes out, already your pouring is completed. But in case if you check the result is wrong, their entire casting is going to be waste. That will come as a return to you as a raw material. That is where it's a biggest challenge. But when I talk about this particular process, I get a lot of counter questions from the few of the customers saying that anyway it is not getting wasted. I'm going to use this as my raw material. It is not going to get wasted. I was not in a position to answer this query, but I got an answer for some time back. One of our past presidents written in IF journal very clearly, very bold statement that dear foundrymen, we are not in the process of making our own raw material. That means you are not here to make rejections and use it as a raw material and proud that, okay, I'm not wasting it, I'm using as a raw material. That is a big, bold statement. I always refer this statement wherever I get this question. Yeah, you are not in the process of making a raw material. You will get a raw material much cheaper price. You have to use that raw material and produce your end result. That is why it is very important that you do proper treatment, and then ensure that you get a better your output is always right. To get things first better, if you analyze is what went wrong, maybe generally, since you are ensuring that the raw material your base metal chemistry is ensuring, I'm sure that every industry must be having a process of checking your ferrosilicon, magnesium, that pickup percentage, the quality aspects, in your raw material inspection stage, and that is being used in the process. The difference would be the charge mix percentage. For example, if your treatment size is 1 ton, if you are using 1% of ferrosilicon magnesium, say about 10 kg, the operator has to ensure that every time puts 10 kg with a tolerance of plus or minus 50 gram or 100 gram, whatever you specify. But if any chance, instead of 10 kg, put about say 9.5 kg or 10.5 kg, and then that goes. But the biggest problem would be that even if it puts 9.5 kg, but the logbook says it's at 10 kg. That is the biggest challenge. And when the result comes out, it comes as a negative. Then you are not in a position to even find out what went wrong, and you are not clear. That is the biggest challenge in this process. What we are trying to do here is that we are deploying our control systems, ensuring that every time when you weigh, and that weighments are ensured that the right quantities are weighed. Like we are operating this similar operation what you saw in the additions in the furnace. Same thing being deployed here. And we introduce our BST, which is near to the weighing scale, and then there is our crane molten metal. Our crane weighing systems are connected with this particular network, and there is a timer. There are people have a timer. The timer is also connected to this network. How this system works? It's like this. This is the terminal which I talked about. This is the supervisor terminal which is connected with the weighing scale through our serial port. Okay, and then you have the data from the computer which knows that how much ferroalloy is required, how much covering metal is required, what is the molten metal quantity is required. All this shows in the system. Then the operator has to follow what systems are talking about. I just run a video so that it gives a clear picture. Your weighing scale, typically you must be having this weighing scale in your plant, and this is the terminal which is rugged terminal. We are not using kind of HMI, which is may not have a long life, with the rugged displays and push buttons which can ensure the long life. We have installations in the market which are more than 7-8 years old. And of course the crane weighing system, the integral type crane weighing systems are connected here. It just comes with the target actual display, how much molten metal be tapped, and is also connected with the timer. This is the process where, as I think you have seen in my earlier slides about this software, where I run this screen so that you already seen this. Yeah, you are scheduling it. Okay, I want this particular product for so many batches. There are two different scheduling. One is for base metal, another one is for the your HG treatment. There are two different scheduling you need to do based on the system will start working. So this is the operator terminal. It gives us steps what needs to be done. It gives the ferrosilicon what grade need to be weighed, what is the set weight, and what is the actual weight. You can see this terminal itself. No need to see the weighing scale. When the alloys are put in, if it is a lower level, there is a yellow lamp will go. You can see it here. He is trying to press the register button. It says weight not okay. It cannot accept the weights because it is below the tolerance level. Same way for higher range, goes to the red, and if you're trying to press a button, it will not accept. That means the band in which we defined, for example, 10 kg, which I explained to you earlier, if your tolerance say about 100 grams, 9.9 to 10.1, it can accept. Less than the 9.1 or 10.1, it will not accept the material. The tolerance are given in your hand. You can specify in our charge recipe master in a computer, that can be changed by the authorized person any point in time. As per the your input, the system would start working. And operator side, he has to ensure that he is following that. Anyway, he will not able to deviate from that process. When you're using a normal weighing scale, you are not having any control. He can weigh whatever he wants. He can write down whatever he wants. Here, you are not allowing them to write down anything. Whatever data is registered, it automatically comes to computer where you can generate the report. The same report can be shared to your buyer, definitely which improve the confidence of the buyer. And most of the buyers are insisting this particular data is system generated to ensure the data secure, data authenticity. So you see this platform, once the payment is registered, you have to remove the platform that material from the weighing scale, and then it will ensure that the weight is reduced from the weighing scale. Then next container is put for your covering material, and it continues the process. Because I'm only explaining the few process, but there are a lot of research have been done and study the process, the sequence of operation has been built in the system, so that that can be configured as per the customer requirement. It can put in operation on a day one, which is much easier, and then it's already tried and tested system. I would say about more than 10 systems in the market. People are using it more, and few of my customers using more than 10 years for these systems. So now the batch is over. Now he has to bring the ladle, and then till the time there is a target weight will come, then he has to press confirm the system that he has dispensed that alloys into the ladle. You can note here, once the batch is ready, he has to manually put that alloys into the ladle, and then he has to confirm that batch is discharged. Okay, that is the manual confirmation we are taking from the operator, because we don't have any other method of confirming here. And once it is done, then people get what is the target weight to be weighed, and you tap the metal from the furnace, and the registration is done to the remote by the operator. Then the timer will start automatically. See, I'm sure that every company would be having the timer, but the challenge would be that whether the operator goes and press the start timer every time. Are you able to confirm it 100%? But here, this automatically triggered from the main centralized system. Based on the tapping confirmation, it automatically triggered the timers. And this timer also can be connected with your, suppose you have a automatic pouring system. The timer can be connected with the pouring system, where it can also have kind of okay control, where when the pouring would be doing it only when the timer is active. When the timer is inactive, it will stop the pouring operation. And this is also one of the most important okay, and most of the buyers are insisting nowadays. And I think we have done this exercise for a few of our clients. Yeah, what is about this the container I talked about so far, the payment, how the system will understand that which material it is. It will not understand. That is why we have the container like this. When the system says that particular bin gets opened, there is a pneumatic cylinder is pressed, that is controlled from our main BST. When that particular material is shown in the display, it automatically opens it. The operator has to manually take the material, put it on the weighing scale. When the measurement is done, then automatically get closed, so that it ensures that the right material, right payments are done at any point in time. And we also have the voice. There are places where we have a voice model. If the people are not able to read out English, no, now we are using migrated labels. You can put their language, the command, like a railway system. It will tell that okay, now the material you have to put this material. The weight is not thick, like whatever the language you would like to have, it can record it, so that it gives a voice intimation to the operator, so that as a baby steps you can follow the system and do the process. That is what this particular talks about. And as I mentioned, this is implemented in close to about 12 systems in the market, and it's all working, and then it has been well being appreciated by many of the customers and OEMs. See here, one more improvement point would be that we have introduced the one more okay. Like I explained that once the batch is ready, there is a batch over is coming, and then the people has to manually put the alloys into the ladle, and then confirm it that okay, I have dispensed the alloys into the ladle. What happened, one of our client where the system was working more than 2-3 years and they never had a phase of problems, and one fine morning after 2-3 years later we got a problem that okay, we had an issue in the system, and instead of making my edgy, and there's a base metal that's gone for a pouring. And it has happened in one particular night shift. Then we were not clear that how it has happened. Then we gone there and then studied the operation. What happened is that one particular operator developed a habit where when the system says batch over, and instead of putting the alloys in the ladle and come back and putting discharge button, what it does is that on his smartness, he put discharge button, then go and put the alloys into the ladle. That has become a practice, And that particular day, what happened? He has pressed the discharge button, but unfortunately, he has not put the alloys to the ladle. Only empty ladle gone to the molten metal tapping, and the base metal has been tapped and gone for a pour. That is the challenge. Now, what we have done is that now introduce the special platform scale for the ladle. Now, once the alloys are weighed, and then we give instruction for the operator to place the ladle on the platform, and then through voice instruction, and then the crane which is used for handle this ladle, the hub hoist of the crane is we disconnect with our output. Only after the alloys are fed in, because we know how much alloys have been weighed in the BST, and only that quantity of alloys are fed into the ladle, then we connect that hub hoist. In prior to that, if they're trying to suppose the empty ladle, they were trying to lift it, they will, even if they try to lift the crane, and that hub hoist will not work, and they will not able to lift the crane. Now that kind of poke control has been created. After this implementation, then it is ensured that every time he weighs that quantity and put it onto the ladle, then only he is taking to the ladle to the tapping. With that, there is no failure at all. And after implementation, now we are cross close about 10 years. There is no single failure in the process. That's the kind of level of poke control and automation can be done. And after that, we have implemented in many of the places. Along with that cases, along with this process, we implemented. See, as I mentioned, like this is the whatever we discussed so far for the AG treatment is for semi-automatic. They are now we have also gone for total automatic alloy feeding systems. It's something something like this. It has got storage silo, and then it got a vibrator, and there is a weigh bin, and underneath there is a conveyor. There is a discharge chute. The chute will goes inside the ladle, and then pre-weighed quantities are dispensed to the ladle to the particular packet. This is the auto dispensing system, and it has been successfully. We have supplied close about more than 12 to 10 to 12 systems in the market, and it has been being appreciated by many of the foundries. And here you need a person to only fill this storage bunkers once in a day or once in a shift, depends on the size what we choose. And it's like a coffee dispenser. Bring the ladle, and required quantity of alloys and covering materials are dispensed to the ladle. This is what we are doing it here. It is something like this. The typical drawing goes like this. You have a storage silo, and then vibrator, weigh bin, the conveyor, then material goes into this. See, the automatic dispensing to the ladle would be possible based on the if it is open ladle, it's much easier. If you are using a Tundish cover, then little challenges are there. That needs to be discussed with your data, and whatever the solutions available, we'll be able to offer it. But for open ladle, and then the chute can go to the particular packet and dispense the material. That is possibilities are there. I just run this video. This is the setting parameters. He does it in the computer as well as in the HMI. This is the forwarding. This is what it is. It dispenses to in a 2-speed coarse and fine. All these parameters comes into the HMI. What is happening there, people can see it. It runs in 2-speed coarse and fine, so that you get a proper quantity. It also displayed in the display what is happening there. Then ladle is brought to the particular location, and then they press the discharge button. The chute goes inside, and then there's a connecting plate. Then dispense as per the sequence. The first is dispensing ferrosilicon magnesium, then covering material, just go to the particular packet. Here the customer will also add inoculants into the ladle. It depends on the customer requirement. then choose goes up. Yeah, then the ladle is taken out for the molten metal tapping, and this is being successfully implemented. I think I was told that many of the core wire process people recommend that no, since the automatic charging is not available, that is why people are going for core wire. One factor. I'm sure definitely there'll be other factors are involved, but for sandwich washers, I would like to record here that now that that bottleneck has been removed, and then automatic dispensing and pre-charge quantities is can be 100% can be charged into the ladder, and that is being taken care, and it is proven in the market. And again, the getting of the raw material for the sizing, required sizing, is much possible, because ferrosilicon magnesium covering materials are available in the market for this particular size. Based on our past 10x installations, we could see that it is possible and it is viable solution. It can be installed for any new plant as well as for the old plant. It will be much easier, and again, all this data can be fed back to your main system and integrate with your SAPs. That is also possibilities are there. Yeah, basically, this is the comparison. What is that semi-automatic or automatic we are talking about? The automatic system, there is a layout change is required, whereas the existing layout can be accommodated for semi-automatic. Then sizing of the uniformity plays a major role here. The sizing is not a much bigger role, and investment, of course, high and low. Manpower reduction is there. This automation, whereas semi-automatic de-skilling is possible. Manpower reduction is may not be possible, and here you got 100% process control. Here close to about 95 to 98% process control. The only thing is, if the people wanted to make a mistake, they can make a mistake. That is attitude issue which has to be dealt in different manner. And automatic data capturing is possible in both places, and more are possible for the new project and for existing plants. And many places people going for combination of this, mainly for SG treatment. The people can think of automatic alloy feeder, and other things they can go for semi-automatic. Both combination can be thought about it. Yeah, coming to the pouring now, people have the total manual pouring operations and then pipe inoculation. That's what people are doing it here. I think due to the time constraint, I'm not showing the video, which all you people are aware of it, or what is this process all about. And then nowadays, this is the typical pouring machine, and this is a lip pouring machine. Nowadays, many manufacturers started manufacturing this, start from Google Wagner to Indectotum, Sakti. Many people are trying to do this equipment, very successful in their venture also. And then there is a volumetric inoculation. There is a inoculation system based on the volume, based on the scoop conveying system. It is being done. It is there. I think maybe a typical video I can show you. This is the system. I'm sure that many of you must have seen the system in our real working condition. That is, this is Sunday's bottom pouring. I think this is also well-known. Bottom pouring is available. I think that is known to you. Again, there is a volumetric inoculations are happening. Something like this. Volumetric condition pouring. See, now I think I understand for this industry that now there is a development of automatic auto positioning. Now, as of now, there is a manual positioning of the lip. The tip pouring is done. They have to position the mold, and then based on the joystick movement, that is pouring is happening. But I think now auto positioning is being done, where the pouring per minute, the pouring speed is getting increased automatically without manual interventions. That is getting implemented in few places. Of course, there are maybe initial there are some issues are there, but I think once it has been tuned, I think people are getting a lot of advantage in the system. And then instead of going for volumetric inoculation, there is a gravimetric inoculation is also available. Uh, there are a few people working on it, and we are also one of the people we are working for gravimetric inoculation. It is under our R&D at the final stage, where we are working this solution along with this Snamolize. That is for the pipe inoculation also, there is an alternate solution. There is a requirement in the market. This is what we are talked about. Smart feed. We have for lateral inoculation, we have already solution available. Only for the stream inoculation, there are certain maybe controls are being building up. Once it is ready, we'll be able to up to the market and then go for it. Now, as of now, there is no much player in terms of gravimetric. It's all are based on volumetric. Volumetric, one of the disadvantage would be if your density of the inoculants varies, then you may lose the or issue. You get a lot of an issue in that. That is one of the biggest challenge. Whereas gravimetric, you can avoid that particular issue. And of course, varying the pouring temperature, as I mentioned, and time control. These are the two major factors. Here you can introduce the, again, as I mentioned earlier, that non-contact pyrometers can be deployed and then monitored here, which is much easier here. So that your temperature drop instead of time-based, that can be controlled by actual temperature-based. That is also one more solution thought about it. And the timer, as I mentioned already, the timers are available because we also have this timers, and which has got a 3-stage timer, which has got a, because when you do a manual pouring and people are asked the question that once the time is 720 seconds reached, you are giving alert, and how do I improve my or speed up my pouring process? Maybe that is why we have given a solution where there are three stage of colors would vary, something like this. I just run this small start video. So initially start with this color. It can occur up timer and down timer. This is 50 to 90%. It gives once across 50%, there is alarm. And then once the 50 to 90% crossed, then there will be a separate alarm, and then color of the display also would vary, so that you know which stage you are, nearing stage you are there, you will come to know. And once it reaches 100%, it moves to the red level, so that you know if you are out of the tolerance level. As I mentioned earlier, this can be interlocked with your pouring machine. If this is out of range, then you can stop your pouring automatically. As a OK can be implemented along with these machines. This is the for your pouring aspects. I think we come to the end of our session. And as I mentioned earlier, that all my inputs are based on the not much on the process side, more of automation on the equipment side. And this is what few input what I can give it from various vendors available in the market, and few of our solutions what we can you can thought of it for your melting platform automation. Thank you very much. And if anything, you have any queries, anything, we can discuss about it now.
Sir,
Hello.
Senthil Kumar, sir. Namaskar, I'm Benkappa here.
Good afternoon, sir. Good afternoon, sir. How are you, sir?
Good afternoon. Fine, sir. Sir,
Yeah.
nice presentation. See, I have one question for you. See, we have a furnace setup. I think you have seen our foundry.
Yes, sir. Yes, sir. I visited, sir.
Can you take up a project like to charge unloading, feeding of scrap, alloy, everything can be mechanized, sir? Can you take up that project looking onto our site condition?
You can take it up, sir, but only thing is it required a little bit of layout changes and then sizing. As I mentioned in the presentation, there's a two factors has to be considered, and one is that you need to put in little bit of efforts to sizing your raw materials, and second would be a little bit of layout changes. Of course, based on your current layout, we can also recommend what needs to be done. And if it is implemented, it definitely possible, sir. It is possible. And I am working with many of the new projects where the project stage itself, there's a lot of customers where we are interacting and giving our input. Of course, sometimes we may not do it, maybe somebody else also do it, but we are interacting with them and giving our inputs whatever is possible. And based on that, the layout stage itself, they are able to build the layout structure, and then they can implement this automation at any point in time. Yes, it is possible, sir. I will take care of it, sir, and I will connect you privately. Then maybe I'll ask one of my engineer to visit once again, have a discussion. Then I can work on it and give up our input.
We are shortly going for an expansion, change in furnace also. We may need your support, sir.
Definitely, sir. We'll do that, sir. Thank you.
Okay.
Thank you. Sir.
Thank you, sir. Nice presentation.
Thank you.
All the best. Thank you.
Thank you.
Any more questions? Sandil sir, actually there are people who are asking your contact details in the chat box. I think actually you can post it.
I'll type it.
So if you don't have any questions, actually we move forward with our vote of thanks. On behalf of Indian Institute of
Sir, 1 minute.
Yes, sir.
Before closing the meeting, we want to say about the next program. About the next program. 1 minute. Dear participants, good evening once again. See, the next program what we are going to have is on 21st of February, Friday. Instead of 4th Friday, the non-availability of the speaker, we are preponing the program by 1 week, and it will be on 21st of February, Friday, between 2:30 p.m. and 4 p.m. And the topic is smart manufacturing technologies in commercial vehicle manufacturing space, which this same technology can be adopted in foundries also. One Mr. Aravind from Ashok Leyland, he will present the paper, and it is very much useful to everyone because we already heard his speech so many times. So better we should listen to him in the next meeting. And if the participants are having any other specific request, some topics can be covered, then they can inform us even now also, or I will give my mobile number. They can contact us anytime. My mobile number is 8939733314. They can suggest the topics also. So with this, I am giving the floor to Mr. Raj Mohan Madhiyagan for vote of thanks. Thank you.
Thank you, Dharan sir. On behalf of Indian Institute of Foundrymen, National Center for Skill Development and Chennai chapter, I extend my heartfelt gratitude actually to everyone who made to today's webinar under the topic automation and economies of operations in melting. First and foremost, I would express my sincere thanks to our esteemed speaker, Mr. P. Sandil Kumar, Executive Director of AC Automation Private Limited, for taking time out of his busy schedule to share his valuable insights and expertise. Your comprehensive presentation on automatic strategies and cost-effective melting operations was both enlightening and inspiring, sir. I would express my sincere thanks to all the participants for making this webinar a successful event. Let us continue to engage, collaborate, and innovate as we move forward. We look forward actually to see you in our future events. Thank you. Thank you, Sandhu, sir.
Thank you. Thank you all. Thanks for the valuable time. Thank you very much.
Thank you, sir. Sir, we would like to
Thank
take
you,
this
Vignesh,
opportunity
and
to.
thank you, Dalan sir.
Yes, sir. Thank you. Thank you, sir. Sir, we also have a program tomorrow from the IAF Chennai chapter, where it is a technical webinar organized by Chennai chapter on the topic effect of trace elements in cast iron, boon or bane. It is being taken by Mr. Balaguru Sendil of Elcom. So you can join us for that also. So we'd like to take this opportunity to invite you for that. And thanks, Mr. Sendil, once again. Thank you.
Thank you. Thank you. Thank you.
Thank you, sir.
We can post the link in that chat box.
Yeah. I'll do that.
Thank you all. Thank you. Thank you very much.
Is